Hey guys, here we go. So let's talk about some applications of parametric equations. Right? Just read through the problem and see what we're going to do here. You're going to see some similarities to what we did earlier this year. Writing parametric equations. It's got some similarities to what we've done before in terms of the wrapping functions, but it's not exactly the same. So if we're looking at this one, a Ferris wheel has a radius of 60 feet and its lowest point is 5 feet off the ground. So let's start with that. Ferris wheel. Radius of 60 feet and it's 5 feet off the ground, so right here is the ground and we have 5 feet right there. Okay, car is located at 120 degrees off the horizontal, so it's going to be starting right about here. I'll put a C there for the car, and in 15 seconds it reaches here, so right there we'll call that car the original car, and that's the new car for ourselves. So I think that sums it up. 60 is in there, 55 is in there, 120 in the 15 seconds. Okay, so let's start to think about writing equations for ourselves. Okay, so if we're going to write an x equation, it's going to tell us the x coordinate at any given point, right? And we're going to see what we should work with. So typically when we write equations for the x coordinate, and if we think back to trig, right, the x coordinate, I'll get it focused there. The x coordinate stands for the cosine, right? So let's try to use cosine for this, right? And I'm going to leave a blank there to account for that amplitude. And the amplitude is 60, because if you think back to wrapping functions, right, the same idea here is that it's going to, if we think of this as 0, it's going to go up to 60, down to negative 60 for ourselves. So that's why our amplitude's right there. Okay. Now let's think about the angle we're going to have there for ourselves. Okay. And right, let's start this. Let's do t in seconds. The reason I'm going to choose t in seconds is because this says 15 seconds here. I could have chosen t in minutes, but either way, I'm going to write it down. T is the number of seconds. Okay, and it's important to note that just so everybody knows what you're talking about. So it's crucial you tell people what your unit's going to be on that time. Okay. So as I'm doing this one here, and as I'm starting this problem, right? Okay, I want to think about the fact that just think about where you started. And where did I start? If I'm thinking about this, right, this angle right here is 120 degrees, right? We're going to change it to radians, right? So I'll keep it as 2 pi over 3. Okay, so we'll make it 2 pi over 3. So that's where I'm starting. So if I plug in a 0 for the time, right, I'm going to find the cosine of 2 pi over 3 times it by 60. That'll give me my x location for myself. Okay, but we have to remember that time is going to be changing, and so it's going to be moving. And since we're going counterclockwise, it's going to make my angle smaller, so I'm going to do a minus. Okay. I'm sorry, since it's going clockwise. Right, as it states right, where does it say that? Speak. Did I forget to actually put that in there? Okay, I'm telling you the directions, right, when I copy this problem are that it's going clockwise. Does it say that? Yeah, so, right, moving clockwise. So let me add that in. Right, that should be given. Should have been given. Okay, so if you're looking at that, just so we know which way it's going to go. Sorry about that. Okay. So, we think about how quickly it's moving, and we just think about it in this time, right? The time is going to be 1 second, 3 seconds, 5 seconds, whatever, right, for myself. I just have to think about how long it's going to take that for this one. So if I'm going to think about my period for this, I think to myself, okay, if it travels 30 degrees in 15 seconds, if I want it to go 360 degrees, that's going to be 180 seconds. So that's my period, okay? So my scalar for this, my b value, right, is going to be 2 pi over 180 or pi over 90. Okay, so that's going to be important. That way if I plug in like 180 for myself, right, it's going to account for it and put this in correctly for myself. So, right, this is going to be pi over 90 here times whatever time, right? So if I plug in a time of 0, right, this zeroes out, and I would just be, the x coordinate would just be 60 cosine of 2 pi over 3. Right? If I were to plug in, let's say for instance, right, that my time is, we have 15 seconds. If I plug in 15 here, right, I have 2 pi over 3 minus pi over 4, right? That would give us pi over 2, right? No, that wouldn't give us pi over 2. It would give us whatever we'd have for that angle, right, for ourselves, right? It would give us that angle of pi over 6 there. Okay, that's what it would give us, pi over 6. Yeah. So anyway, it would give us our correct location there as we did that, right, for all of our given times there. Right? Okay. So now we think about that y equation, and we're going to use a sign for this one because y values are given by our sine curve. Typically, think back to trig, like, right, and our opposite and adjacent, right? Y is the opposite, and that's our sine. Right? Again, we're going to have 60 there because that's our that's our amplitude as we go up and down there, right? The 60. Okay. Right. Again, our angle is starting at 2 pi over 3. Okay. So if we were to plug in 2 pi over 3, that gives us an initial location. Oh, but we do have to remember that the y has been moved up 5, so I'll put a plus 5 here, right? And maybe you want to put that first there for this one, just to make sure. Oh, I'm sorry, not plus 5, because we're thinking about this. We have to go off of this location, sorry. So it's actually going to be plus 65, because I'm coming off of that. So it's not 5 to here, it's 65 to that baseline. Remember, that's our midline, baseline, our axis of symmetry. We thought about it before. Okay, so that's why it's 65 there, right? We're rotating around that point. Okay, we didn't add that on x because x was on the y-axis. It wasn't getting translated left to right. But the center of this Ferris wheel, this circle, has been translated up 65 spaces. So that's why we have that plus 65. Okay, we're also going to have minus pi over 90t. Again, because we're moving in a clockwise direction there, right? Our angle is getting smaller, right? And because that period isn't going to change. So we have our equations for this, right? And again, remembering that we have this in terms of seconds. If you wanted this in terms of minutes, well, that would, that's going to change things. You would have said t is in the number of minutes, right? This would stay the same, that would stay the same, and then you're just going to have this number change right here, okay, for ourselves. So that's the only difference, right, as we work through that problem. Okay. Okay, so we have our equation there for ourselves in terms of seconds. Okay, so let's take a look at the next part. At what position is the car located after 2 minutes? So remember, I have my time in seconds here, so I'm going to cross out 2 minutes. I'm going to make it into 120 seconds, right? So that I don't accidentally plug in 2. If I plug in 2, wrong units there. Right, and so if you're just looking for the position, then you just take that and you actually plug it in, right? 60 cosine of 2 pi over 3 minus pi over 90 times 120, right, for yourself. And you just kind of, now at this point, it's just plug it into the calculator, see what you get. You get negative 30. Okay, what does that mean? Right, we should really interpret this one, right? So it's going to be 30 feet to the left. Okay, for the y, and I put it in the bottom because I'm kind of summing up my final answer. I could do it as a coordinate point, right? But I was just trying to treat this more like a word problem for myself, right? For the take the other equation, plug in 120 for that, right? Figure out what I get there. That reduces to 4/3. Hey, that's like, so it's the 60 signs of negative 2/3 for myself, right? Being a word problem, and we'll just worry about it. We'll just worry about the 13.038 we put into our calculator. Right? Just plug it right in and see what we got. Oh, I forgot my plus 65 over here. Right, as I did that. Okay, so I get the 13.038. So it's 30 feet to the left, and it's 13.038 feet off the ground. Yes, I did round here. Usually I like to know what we're going to round to, but if it doesn't state on word problems, right, which should, right, but we'll go to 3 decimal places. We're trying to get used to AP. That's what AP is going to do whenever there's a rounding situation. Okay, so we got our location. Let's look at part C. At what time does the car reach the bottom of the Ferris wheel? Okay, so that's this location right here. That's our bottom. Okay. For ourselves. Oh, sorry. There's our bottom of the Ferris wheel right there. Okay, so we want to know when it's there. Now, so the thing about that is, great. Okay, we know what our location is going to be, right? And we have to think about which equation we're going to use, and we could set this equation equal to 0, or this equation equal to 5, and we have to pick which one. And so I'm going to choose this equation equal to 5 because there's only one time that occurs. If I set this one equal to 0, I'm going to have 2 times. I have this one and this one. Obviously, I could just ignore, right, the top one because I know it's the top one. It's the one that happens first. Totally valid. It's completely up to you. I'm going to pick this one because there's only one, and I can eliminate that whole, I make a decision at the end. It's like kind of like I can algebra it. And I like, there's only one answer. Here's what it has to be. So that's why I'm going to set it equal to 5. Okay, so I plug that in. Okay, for myself. Right, I move the 65 over. Divide by 60, so I have -1 equaling sine of this quantity. Okay. We know that sine is going to equal -1 when it has a value of 3 pi over 2, so we know that we are 3 pi over 2 equaling 2 pi over 3 minus pi over 90t. Okay. At this point to solve it, there's lots of different strategies. I'm going to scale everything by 90 because I hate dealing with lots. I don't like making common denominators, right? So if I scale everything by 90, right, that's going to give me 135 pi, and that's going to give me 60 pi there minus pi t. Hey, look, all the pi's can cancel. Excellent, those are gone. Move that over. I got 75 equals t. And I move, let me make sure that I got all my signs right there because it looks like I'm getting Yep, just all the signs look good. Okay, so this was a negative though, right, for myself. So that's just saying, hey, I went back in time by 75. So that means like if I had from the beginning, if I had 75 seconds before this, that's when I would have been there. I'm just going to add 180 to it because that's my period. So remember, it's going to happen over and over again. It spins around. I just want to make sure I'm considering what time going forward. Again, the problem here maybe could have been more specific. But that would probably be my best answer there. Okay, all right, 105 seconds. Okay. If I had solved the other equation, I would have gotten 2 answers. I would have gotten 105 seconds, and I also would have had this one, which is 15 seconds. And because I knew from the given problem where 15 seconds was going to be at the top, and I also knew that's rotating clockwise there, then I could have just eliminated that one and just had those one answers. So all right, that's how I solve that type of problem. Okay, let's try example 2. And you know what, guys? Now would be a great time to hit the pause button on the video and try the problem, right? See how you do, right? Check the answers online. If you don't get it, then you can just watch the video, okay? So that's really what I want you to do over the next couple weeks as we're doing this, as I post these videos. Right? Watch me do a first one, and then try to do it on your own and use what you need and check your answers, okay? I'm going to be posting all these solutions online for you, right, to help you out. Okay, so hit that pause, right? If you at this point, if you feel like you can at least try this one, and then start playing it when needed. Okay, so let me tackle this problem, and I'm just going to refer to my original notes, right, just to make sure I didn't miss anything like I did last one with the wording. Okay, so an object is thrown from an initial height of 10 feet with a velocity of 96 feet per second at an angle of 30 degrees.